welcome everybody to the July Global R&D Meeting. And I guess today is a bit different from the usual ones because we do no longer stream live to different channels, but rather do it on a Zoom meeting, record it, and then distribute the recording later on YouTube. So to make the load here a little bit easier to handle, and because we still get about the same amount of people. So on the next slide, we have like a nice agenda today as well. And we got some feedback that people actually would want to have like the updates and the feature discussions like early on, like together, not interspersed with demos, so that if people are really interested in those updates and feature discussions, they have that together in a bundle, and then can skip the demos later on, so it's easier to get to some of the meat of the meeting. So we'll do that today. First, we have some updates on Ethereum, like the status, where we are with Ethereum integration and what's coming. And then we have two upcoming features that where work has started. The first one is like how can we allow users, developers to install larger WASMs, how that's possible on ICP. And then the second part is also about WASMs. It's like when WASM gets compiled and uploaded, it's instrumented on ICP to cater for cycles accounting. And so there's some changes that we're working on on that. And then we have like our good old demo blogs. First we have Boom DAO presenting. And then we will talk about the one proposed lesson as initialization that is upcoming, a nice way to deploy canisters onto the playground. And finally, also how one can pull canister dependencies off the internet computer and run those guys locally, like all of these things, making developer lives much easier. So let's go towards the updates. And actually, maybe the first update here is just like a reminder that vetKeys or like APIs are available. People can go and use those APIs. I mean, right now they're marked like a canister, but these are the final APIs, and so people can start developing while the crypto team and other teams are finalizing the implementation of all the threshold cryptography. So vetKeys are like verifiable threshold keys that canisters can have. More is on this blog post, a lot of stuff there to read and demos and whatnot. So just wanted to do that. Please go code. There's some bounties as well. Very excited about that. So having said so, I want to give the floor to Ben for the next slide about where we are with Ethereum integration. Ben, please take it away.
Thank you, Jan. This is Ben from DFINITY's product team. I would like to give an update on the Ethereum and ICP feature spectrum. There are three big parts. The first, which is protocol integration, which allows IC canister smart contracts to interact with Ethereum. It consists of two stages. The first stage is HTTPS outcalls, and the second stage is like what we did for Bitcoin, so have native Ethereum nodes running on the IC. The reason is for people to be able to develop more complex business logic on the IC and interact with the EVM chains, so really to leverage the IC storage and computational power to build more complex dApps. The timeline for phase 1 is now, so it's ready. You should go out and try it. And for phase 2 is sometime in next year. The second big chunk is the CK tokens. These are multi-chain tokens, so two-way multi-chain tokens. These are verifiably asset-backed by TEC-DSA. They would allow faster and cheaper transfers of Bitcoin, Ethereum, and other EVM tokens. And it would allow easy integration with smart contracts on Ethereum on the IC. The timeline is CK-ETH and CK-USDC. The expected timeline is Q4 this year. And then there is also the other direction, meaning CK-ICP and CK-ICRC tokens on Ethereum, which will be done sometime next year. The third big part, which is EVM compatibility. So there are several smaller initiatives to this, most of which are pioneered by the community developers. So the first one is EVM on the IC. There is DFINITY, which is already have the testnet live. And then there is also the initiative from IC Lighthouse and a few other teams with running Ethereum RPC on the IC so that people can use existing developer tooling and user tooling to interact with smart contracts on the IC. The timeline is for the EVM, the testnet is already live. And for the other initiatives, those are community driven, but we expect somewhere around Q4 2023. I would hand it over to John to present the phase one of the Ethereum integration.
Yeah, so this is John. Phase one of the Ethereum integration is a relatively simple proxy, just proxy from the Ethereum JSON RPC request coming in to a canister and library that we created that then makes HTTP out calls to public endpoints like Cloudflare and Fura, public node, and whatever. And so the idea of this is that users can use it as a library, or they can deploy the canister and then they can use their own dApps, possibly using threshold ECDSA to sign those requests and then forward them on to the larger Ethereum ecosystem. So in phase two, we'd like to integrate Ethereum nodes onto IC nodes on a special system subnet. This has a number of advantages. First of all, it'll allow us to connect directly to the larger set of Ethereum nodes, which means we're not going to have to go through, some sort of a centralized gateway. Another thing is it will be a lot cheaper to do, because instead of making generic HTTP out calls, we're making a local request to a node running co-located. And another advantage is that we'll be able to make some small changes to the Ethereum protocol, which will allow us to do point-in-time requests, which will make it easier to achieve consensus. And so, but because it requires a bunch more work, this is going to be done a little later. All right, so this basically just sums it up. We've got phase one, which is just the proxy. The main thing here is that it's available for users now as a standalone canister or as a library. And then when phase two comes along, it's going to be compatible with phase one. And so there should be a nice gentle transition between the two, and it'll just work better and cheaper. So this is the current state of phase one. We have a repository. It's sitting out on GitHub under a new organization, Internet Computer Protocol. It's over there because it's being donated to the community. It's something that they can extend, they can modify, they can work on. In addition to just the simple proxy functionality, it provides some other functionality. It has a preset collection of public endpoints. It supports, having API keys and the ability for providers to register API keys and set their own cost per call and per byte, and for them to withdraw those cycles so that they can convert them back into ICP and money so that they can pay whoever this public provider is. It also provides some examples of best practices in terms of documentation, authentication, logging, metrics, et cetera, et cetera. But most importantly, it's ready for the community to use and to contribute to and to extend as they want. And it's going to be, as I say, compatible with phase two.
Thanks, John. So the ICP and Ethereum, those three big categories of initiatives really presents huge opportunities for developers in the ecosystem. I've listed some of the potential use cases and products and developers can build. So for protocol integration, the typical use case is, for example, multi-chain, multi-sig wallets, on-chain governance systems for Ethereum DAOs on the IC, because IC has this capability to build complex governance systems, which is not really possible on Ethereum. So a lot of these things are currently being handled off-chain. And then smart asset management, cross-chain DeFi aggregators, and developer tooling products to enhance EVM capabilities. Products similar to what Chainlink and other automation products are offering. And then for the CK tokens, this really allows developers to build centralized exchange-like trading experiences because of the speed and the throughput that we can handle and the ease of the token integration. And other DEX products include derivatives trading, lending protocols, or algorithmic stablecoins. Those present huge potential, and they have already verified business models, so that we would really like DeFi developers to build them. And then there are also merchant P2P payment solutions. This will be leveraging the ease of our internet identity. And then because of the speed of the transaction and the finality, we can really enable those kinds of payment scenarios, whereas it's currently not practical, not possible today. And then there are also GameFi, SocialFi applications that with the CK tokens, we could enable new subscription models, new paths to monetization, and different kinds of use cases. And then for Ethereum compatibility is really about bringing existing developers that are contributing to EVM ecosystems over to the IC with the tooling that they're familiar with, and also leveraging existing users on EVM chains and the TVL of EVM chains to integrate with the IC. So the message here, I think, is really there are a huge range of possibilities that present a lot of potential value. So developers, please, you should start building now. A lot of these toolings are already out there, so it's already possible to build. And then for things that are still pending on DFINITY to do the development work, we have communicated clear timelines. So it would be beneficial to build the product and test, and then have a release that is pretty much aligned with what we are planning to release our features. Thank you very much.
Thanks, Ben and John. So let's move on to work that is just about to be started, or actually this is the kickoff to this work, so to new features that are coming. The first one is about larger canister WASMs, and Adam, how can larger canister WASMs be installed?
Yep, thanks, Jan. Hi, I'm Adam. I'm on the runtime team, and so this feature is basically just about allowing developers to easily install much larger WASM modules in excess of 2 megabytes, which is sort of like the first limit you'll currently hit when trying to deploy large WASMs. And why do we need this? Well, I mean, many community members have already hit these existing limits and have complained about them, and a bunch of dApps are getting larger and more complex, and this will unblock them, allowing them to much more easily grow. And the basic way this works is that we'll add a new interface to the management canister, which allows uploading a WASM module in various chunks and then installing it from a bunch of chunks that have been already uploaded in separate messages. And also, this will get integrated into DFX. So if you're just using DFX and deploying with the DFX deploy command, that command should, under the hood, do all this chunking for you so that you don't need to worry about it as a developer. So the current situation looks a bit like this, right? When a developer wants to deploy a canister on the IC, they send a message that says an install code message, and it includes the WASM of the canister they want to deploy. And this message has a 2 megabyte limit just because we have a 2 megabyte limit on all ingress messages and cross subnet messages. That's just a general constraint of the IC, right? So just because of that message limit, well, if the WASM has to fit in the message, it is also constrained to be 2 megabytes. So this is the proposed solution we have for doing chunked uploads. Basically, if you want to install a larger WASM, as you see in this picture, you'd send many messages to the IC. You'd send a bunch of these messages that say, here's a chunk I'm uploading, and you give it a little piece of your WASM module, and then you'd upload another chunk, as many chunks as you need. And then at the end, you'd send a single message that's an install code message, but instead of containing the WASM, it just has references to these chunks by some IDs. So each message still stays under this 2 megabyte limit. We don't have to change anything fundamental about the IC's infrastructure, but you can install a WASM module that is much larger in its total size. So that's the basic design. So Yeah, how will this actually be used? As I said, the idea would be for DFX that this all gets handled under the hood. Like DFX will just, when it builds your canister, if it sees that it's over the 2 megabyte limit, it will just automatically break it up into chunks, do the chunked uploads, and then do the install. And, I guess you'll see some extra output if you're doing debugging or something, but it'll behave essentially the same way. You can still do gzipping if you've been using the ability to gzip your WASM before installing it. You can still do that. So you can gzip and then chunk it if you end up with gzip WASMs that are over 2 megabytes. But this still won't allow us to let WASM modules be as large as you want. There are other limitations beyond this message size. And the main one is basically compile times. Large compile times. When you have a canister with a large WASM, it may take a long time to compile, which could then cause a very long round if we need to compile your WASM during a specific round. So we will still need to have constraints to limit the compilation times until we can figure out some other solutions to gracefully handle long compilation times without letting them interfere with the performance of a subnet. We'll still need to have some limitations for a while until we can figure out other solutions to those parts. And yeah, that's basically the whole design. Thanks to Bogdan. He did most of the work for this. He's just out, so I'm presenting it. Yeah, that's all.
Thanks, Adam, for all this good news. There's another issue with WASM instrumentation or WASM right now on ICP, namely how it's instrumented, which means how like breakpoints and stuff, or not breakpoints, but code is inserted so that cycles can be accounted for. And so we're like looking into this and want to make this better. So Alex, you have all the news, please.
Yeah, thank you, Jan. Hello, everyone. Nice to see you again. Yeah, so just like Adam has showed us before, how larger WASMs can improve developer experience. I'm going to talk today about our proposal for a new WASM instrumentation, which ideally will also improve developer experience because they will have more efficient and faster canisters written in JavaScript or Python. So the main aim of this new WASM instrumentation is to actually bring performance improvements for certain kinds of applications, such as interpreters for those kinds of languages that I just mentioned. And the way to actually do this is, a pretty large rework of the instrumentation algorithm. And on the next slide, I'm going to explain in more detail what instrumentation actually is. So I guess everybody is quite familiar by now. There's developers. Developers like to build canisters. These canisters can be built in Motoko, Rust, and other kinds of languages as well. They get compiled, they get this WASM binary that Adam was actually talking about, and then the binary gets uploaded on the IC. I guess it can be uploaded in chunks or not, doesn't matter. But then there's this extra step that the ICP replica actually takes to introduce tiny snippets of code here and there, because the IC replica needs to keep track of the amount of executed instructions. And there's several reasons for that. One very clear that I can give you as an example is because ideally messages wouldn't execute forever. So we need to know how many instructions are executed in the message so that we can have these nice rounds that have certain limits. On the next slide, I'm gonna actually show you how this works. So on the left side, there's this uninstrumented WASM binary. So it's a very, very simple example. It just adds two numbers, 1 and 2. And on the right side, what happens is that the ICP replica introduces this instruction counter, which is initialized to a limit. And before each of these code blocks, what happens is that the IC replica decrements the instruction counter by the number of instructions. So in this case, it's 3. And if the number of instructions falls below 0, there's some actions that the replica needs to take. And as I mentioned before, there's several reasons that we need to actually do this. One would be charging for cycles. The second one would be scheduling, because DTS needs to know how to properly split up messages into shorter executions. And if we go to the next slide, I'm going to show you what this has to do with interpreters. So as I said before, interpreters should be faster with this new instrumentation. So Interpreters, basically, what they do is that they take a input program and they look at the instructions, let's say one by one. And then for each type of instruction here on the left, so let's say there's 3 types of instructions that could actually happen: addition, subtraction, and multiplication. The interpreter actually executes some code that represents that instruction. But as we all know, on the IC, we can only execute WASM instructions. So this high-level code needs to be translated into some WASM. And in certain cases, and it's actually happening in practice, interpreters get translated to something like what we have on the right here. So basically, if there are these 3 types of operations that we want to produce code for, what would happen is that we have these 3 nested blocks. And then for the innermost one, what happens is that the WASM code looks at the type of instruction and then jumps to whatever needs to be executed. So that's a very, very simplified version of what should happen. Now, if you go on the next slide, I'm going to show you what happens for the old instrumentation. So basically for the old instrumentation, that's very, quite conservative in terms of how it looks at instruction counters. And it actually introduces blocks of instructions to update the counter at the beginning of each of these blocks. And that's good, but it adds quite a bit of extra code, which is inefficient. And in some cases, it might also miscount instructions. Now, we can definitely optimize that. And if we go to the next slide, I'm going to show you how that can be done. So basically, if we move these snippets that keep track of instructions and update counters, we move them toward the end of the block, toward what actually happens in the block. What we achieve as a result is basically that the update counter only runs whenever that block is actually executed. So that's quite an optimization, makes things quite fast. And if we go to the next slide, I'm going to show you some performance examples. So if we run workloads, something like SQLite kind of workloads, the performance improvement with these kinds of modifications are about 1.5 to 3x improvement. So that's quite nice. But for interpreters like QuickJS for JavaScript, the performance improvement is huge. It's like 34 times. And that's all very nice. But if we go to the next slide, I'd like to talk a bit about what the expectations should actually be. So as I showed before, there's some changes we add to instrumentation to make interpreters faster. That's not the only change that will happen. The change is much more complex. And it's actually a complete refurbishment of the instrumentation. So as I showed before, the interpreters will benefit significantly. So basically, people will have canisters written in Python or JavaScript that will be faster and more efficient. However, performance is actually expected to be as it is now for most types of applications. But because, there's lots of changes, lots of moving parts, there could be some regressions for some applications. So not everything will be perfect, but these regressions, we hope they'd be minimal. One other nice feature here will be that based on this new instrumentation, there's going to be hopefully some improvement in the stability of the finalization rate. And I'm not going to go into the details of why that is. We're going to write a forum post with all the details possible quite soon. Also an NSPro proposal, so actually stay tuned for that. We plan to release a DFX version with this new instrumentation so that developers can test out and see what the implications are for their kinds of workloads. So again, all the details will come soon on the forum. And many thanks to Runtime team colleagues, Andrei, Maciek, and Ulan. Thank you.
Thanks, Alex. Great stuff. So we come to the demos, and the first one is by Boom DAO and gaming. So I'm looking forward to some gaming and some Boom. Please take it away, Max and Thomas.
Hello, hope you guys are all doing fantastic. So My name is Tommy. I am the co-founder of Plethora and a core contributor of BoomDAO. So let's dive right into it. BoomDAO's mission is to build the infrastructure for the next generation of fully on-chain games and provide a collaborative hub for all things ICP gaming. So what exactly does this, why is this important? And I have here the architecture of a traditional game. And as you can see, there's a game client, a game server, and a game database. And the game server and database are running on AWS and are completely centralized. So what does a fully on-chain game on ICP look like? As you can see here, you have your server canister, you have your database canisters, and there's many database canisters to allow for infinite scaling as more users join your game, as well as NFT and ICRC canisters that talk to your server canister. So what if I told you that most games on ICP are actually only the game client, and in some cases run their servers on AWS and their databases on AWS? And the reason for this is that building all this stuff on the right takes months and months of development by really experienced game engineers who have built MMOs previously, as well as have experience building canisters and Motoko. And so what BoomDAO basically set out to solve is, how can we build all this stuff on the right so that game developers can basically have it fully set up and running and configured in 10 minutes. So that's a good segue into basically all of BoomDAO's products. And so first, I'm going to talk about the game launcher. And the game launcher basically set out to answer this question. Can we make it so easy to launch a fully on-chain game that a 14-year-old could do it? So I'll go really quick to the game launcher here, and I'll go over this super brief, but basically this, you can see there's a bunch of games that are showcased here. And something to clarify, all these games are the game clients. So none of these games have smart contract code. This is just basically the game client being hosted inside of an asset canister, right? And so let me hide my meeting controls. And so basically, like, what we did was we made it super easy to upload your game client. You basically can drag and drop your files, and in one click have your game client deployed to a canister with all the canister settings configured correctly. So no need to download DFX, set up a Cycles wallet, configure all the canister settings, all of that stuff. Basically now a game dev can deploy a game client in one click. You can also see that you can launch an NFT collection. You can do airdrops, minting, burning, configuration of images, and the same thing for ICRC tokens. You can create an ICRC collection and do minting and payments in your game. And I went over this really briefly because I actually want to focus this presentation on the next product in this list, which I believe and BoomDAO, has conviction will have the potential to revolutionize the Web3 gaming industry. And that product is the World Engine. So the World Engine is basically answering this question. How do we make it easy to build a game server and database on chain? And so if we go back to that original diagram that I showed at the beginning, this is the diagram of an on-chain game. Basically, the World Engine takes everything on the right here, and we basically created the World Engine protocol. So the World Engine protocol, as you can see, is basically all the servers of your game talking to one central protocol that stores the database canisters of all the games of all the servers. So what we've also done is basically rename all the servers to be called worlds. So basically all these world canisters talk to the protocol, and all these world canisters, as you can see, are composable and interoperable with each other by default because they're all connecting to this protocol that shares all the data across all the different worlds. And so I'm going to stop showing you guys boring diagrams here, and I'm going to show you what it actually looks like in practice. So if we go back to the game launcher, and we'll go to this tab that we skipped over last time, it says deploy worlds. You'll see that you can create a world, and I've already created 2 worlds here for the sake of time. And you can click on a world and you can configure that world, and that'll take you to the candid UI of your world. And remember, a world is basically your game server. And so basically in your world, you can configure actions and entities. And actions are basically the rules of your world. So things like, can you do a quest? Can you, fight a dragon? Can you do a race? And what do you get in return for doing those actions? The game server basically has the job of validating those actions and then ensuring that the game economy is being run correctly and not being cheated. And then entities are basically the items, objects in your world. So they can be things like item, buffs, achievements, basically anything that's in your world. And so real quick, I'm gonna just show you guys how to create an action here. Super simple, we'll create a quest. We'll call the tag a quest. And an action constraint is basically, the constraint for that action. We're gonna give it a time constraint. And basically this is in nanoseconds. So I'm gonna try to guess what 1 minute in nanoseconds is. But basically we're gonna set it to basically you can do this action once per minute. So you can do this quest once per minute. And we'll give this quest a name. We'll say, fight the barbarians for gold. We're gonna do a barbarian fight and get some gold. And you can see you can specify outcomes for this action. And outcomes are basically a bunch of different random outcomes that you can set weights for, how likely this outcome would happen. For the sake of this, I'm gonna keep it simple. I'm just gonna have one outcome with a 100% chance of happening. And basically this outcome will give you gold. So EID stands for entity ID. We'll specify that it's a gold item. The GID is a group ID, so it falls into the group of items. And the quantity will say you get 200 gold if you finish this quest. And you'll see there's also a WID, and that's an optional field. A WID stands for world ID. And basically this is really cool because it's basically you can change the entity. You can add like an item into a world that's not your own. So let's say if we had Cubetopia, running as a world, I could basically specify Cubetopia's world ID here, and my player in Cubetopia would get a 200 gold if they did this quest. But for the sake of this, we're not going to use that. We want to get the gold in this world. And then you can also specify an action plugin, and these are basically custom plugins that any developer can write that add additional functionality to this action. So you can see like you can verify ICP transfer and ICRT transfer, that a person burned an NFT before doing this action. We're also not going to use that because we're going to keep this simple. So we can go ahead and create this action. We got an all good. So now we can go down here and let's do the action. So we'll go to the process action function, and we'll just specify the action ID. So we're going to do the quest and we're going to call it. And boom, just like that, we got 200 gold for doing this quest. And you can see if we go up to check our entities, you'll see that we now have 200 gold. So one other feature that I want to show about this is that once you've configured all the actions and entities in a world, you can actually import all the action entities from other worlds into your world. And so basically the reason for this is for being able to extend and mod other people's worlds, because smart contracts are open and permissionless. And this is really the core feature of smart contract, is that you can coordinate millions of people around a smart contract. So these are all the worlds that people have created. I created a world earlier today, so I'm just going to use that one. But basically I'm going to import the configurations and actions of this world into the world that we're currently in. So you just go to import world data. You can import the configs, which is what I'm going to do, or you can import even all the users, like all the user data of all the users of that world into your world, and then start modding it. So it already imported, and we're going to go back. And now if we get all the actions in this world, or actually it's this one here, if we get all the action configurations of this world, we can see now we not only have this quest action, but we have this crafting action, this minting action, and these are basically imported actions that we just imported from another world. This crafting action, I believe, it takes 200 gold, and then you get 1 sword for doing the crafting. This minting action, you can basically mint an NFT, and that directly talks to the NFT collection that I created earlier here to mint the NFT for you directly in game. And so I'm gonna move on to the next thing because I don't want to be using too much time. But this last infrastructure that we built is the Unity template. So I've shown you guys kind of like the back end of the game and basically all the on-chain features in the game economy. But of course, game players want to see a cool game, right? They want to see cool graphics, fun gameplay. That's what they get excited about, get immersed in. So the issue is, how do you build interoperability between the Unity game engine and the internet computer? So we've built basically a template with all the features necessary to build a game in Unity and talk to the IC. So we have a white label shop that has actions for purchasing an offer with ICP, with ICRC, trading an item for another item, buying an NFT. We have a marketplace, fully featured. You can buy, sell, list NFTs, and you can replace the NFT collection to whichever one you want, fully integrated directly in Unity. We have staking. Basically, it's similar to the NNS. You can stake ICP, ICRC, NFT, then there's a dissolve delay for unstaking them. You can burn an NFT and get a random reward. But basically, this is the culmination of over a year of R&D. And the goal was really, how can we make it so that other developers don't have to spend a year building all this infrastructure, and instead they can use the infrastructure that we've built to build a fully on-chain game in a matter of hours. And so, I'm running out of time, so I won't. I had a bunch of other demos I wanted to show, but I'll just mention that Cubetopia, Plethora, and a number of other games are building on top of the World Engine, and we're really excited in the upcoming weeks to kind of show you guys some interesting things coming out for that, as well as there'll be a gaming hackathon in the next month or so that's being sponsored by DFINITY, and that there'll basically be a gaming track that's focused on leveraging the World Engine. And so we're really excited to get a fresh new wave of game developers onto the IC, and get them to use the BoomDAO infrastructure to be able to build their games in a matter of days and not months. And so thank you guys for having me, and that's BoomDAO.
Thanks, Tommy. Wow, boom, very cool. Looking forward to all that is coming out of here. I guess I've heard looking into SNS that's coming up soon, so that's a good segue into the next topic, like the work on how making life for people like Tommy easier to submit SNS proposals. So Daniel, please take it away.
So hello, IC people. For those of you who don't know me, my name is Daniel Thoreau. I'm an engineer on the NNS team, and I'm back to present even more SNS updates. Today, I want to talk about a big IC feature that's nearing release. And as you can see, it's named the One Proposal SNS Initialization. And as hinted by Jan, I'm hoping that it's going to improve a bunch of different participants' lives in the SNS launch process. So let's get into it. So what is it? Well, this initiative took aim at simplifying the launching of an SNS for all the parties involved, as mentioned. We looked at the design and the UX for the various participants, and we tried to eliminate as many manual steps and repeated work. Why did we do this? Well, we've had quite a few SNS launches since the first SNS1 DAO, now the Dragon's DAO, was created back in November of 2022. We've collected quite a bit of feedback and really saw what the pain points in the ecosystem was. We most importantly understood how difficult it was to get an actual SNS launched by devs using just the MVP product. There were multiple proposals, configuration steps, manual API calls, and in this new initiative, we've aimed to eliminate almost all of those steps, as you'll see later, and make the process as automated as possible. We also didn't forget the NNS voters, and we saw how confusing it was to have those multiple proposals that you weren't exactly sure what the outcome of each one was going to be. We've aimed to put this all into a single proposal now, with all the configuration in that single place, and the adoption of it being all or nothing. So now you know the what and the why. How do we do it? Well, with this release, which is slotted for early August, a new proposal is going to become available under the SNS and Neurons Fund topic. That means all of your previous following is going to still be set up. There won't be any new configuration you'll need to do. And the name of this new proposal is Create Service Nervous System. We tried to be very direct with this one. If adopted, it will autonomously spawn an SNS and open and close the decentralization swap without any user input. So we think it's a big improvement. Now, before I get into a demo showing the new process, I just want to compare and contrast what the previous method is for those of you who've never gone through it and show you how much of an improvement the next one is. So first, I'll go through the legacy method. To start, devs had to submit an NNS proposal to whitelist a principal in the SNSW canister. For those of you who aren't familiar with the SNSW canister, it's just an NNS canister that's responsible for deploying and upgrading SNSs. This proposal type acts as a sort of authorization from the NNS for a principal to be able to deploy a single SNS in the future. The NNS voters would see this in whatever your favorite client is. I've just taken a screenshot from the NNS app, and it does exactly what you think, right? It just adds a principal. If this is successfully adopted, then it goes back to the devs to be able to configure using the local SNS CLI binary, and then request to deploy that configuration. Most notably, you don't actually specify all the configuration in this previous method. You'd only do a subset, and the most important ones, which is the decentralization swap, is specified later. If this goes all well, there's now an SNS deployed to the SNS subnet. Note, now no NNS voters have actually seen this yet. They've only voted on the NNS proposal. At this point, the SNS is in like restricted mode, and the developers' neurons are in restricted mode, and then they have to register the dApps, and there's a little bit of manual work still required. And then on top of that, the devs would then have to submit that second NNS proposal to open the SNS token swap. At this point, this is when NNS voters would usually go out and verify whether this SNS actually matches the configuration that these developers would syndicate on the forum or any of the other places. And that was a little bit of manual work on the NNS voter side. They'd also then actually have to go and vote on this proposal. And if rejected, the SNS would return all the dApps to the users, and the developers would have to try again. It's kind of an annoying process. And finally, if it was adopted, the decentralization swap would open. You'd have all the participants go through, and if the correct conditions were met, there'd still be a final API call once the swap automatically commits to distribute the SNS neurons. That's a huge amount of steps, and I really hope this puts in perspective how great the teams who have gone through one of these SNS launches have been. They've really knuckled down and gotten it done. But without further ado, I want to really show how simple and what the new process is going to be. So first off, the first step for the developers is to just merely add the NNS as a co-controller. There's no longer any need to register your dApp once the SNS is deployed. The first step, you just add the NNS. We've added a new subcommand to the SNS CLI that makes this a breeze. I'll be showing that later in the demo. And then you go through the same steps of configuring the SNS. We found that the YAML config file was really a big success, and we've done some overhauling of it, but most importantly, you can now configure every single configuration parameter in that initial config file. There's no longer two separate proposals and a bunch of other steps. You actually even specify your dApp there. Now, and also instead of deploying the SNS through a manual call, all you do is submit the NNS proposal through that same SNS CLI. And that's the last manual step for devs. That's it. Now, for NNS voters, instead of having multiple proposals and have to go investigate yourself, you just get a single proposal with all of the proposal information in there. So you'll see every single SNS configuration parameter and even the dApp canisters that are going to be part of the decentralization swap. Awesome. Now note, there's no SNS created at this point, so there's nothing to go review. And only after this proposal is adopted does the autonomous creation of an SNS start. Now, I've put this in the dev column, but I put the cogs there to really represent that there's no manual work. If adopted, NNS governance is going to request the SNSW canister to deploy the SNS, given that configuration file. And also, because you've added the NNS as a co-controller of your dApp, the NNS is going to autonomously transfer control to the SNS. At any point, if something isn't going the correct way, we've done quite a bit of code and security review to make sure that these dApps are always returned to the original developers. So there's no risk of losing control. And finally, because of all this configuration that's present in the NNS proposal, the swap can now autonomously open, commit, and finalize. There's no more user input needed. And that's it. That's the new process, right? So much easier than the last one. And I'm really looking forward to having some people test it out and hopefully getting some good news on how easy it was. So I'm just going to now show the demo. So I have a developer experience here on my left and what the NNS voter experience would be on the right. I'm using the SNS testing repository. This is a testing repo that the NNS team vends on GitHub. I'll include a link later on in the chat. And it's just meant for anybody who's a prospective SNS dev team to be able to test their configuration locally and go through a bunch of different steps that is included in this process. It really makes your testing easier, we hope. We've already included some one proposal feature support, but there'll be even more on the day of release. So keep an eye out on the forums to hear about that. Anyway, let's get into actually seeing what the improvements are. I want to start by looking at the overhauled configuration file. Now, I'm not going to contrast it with the last one, but anybody who's gone through an SNS before knows that it was a flat structure. There's many configuration parameters. There's lots of comments, but we tried to make it simple and a little bit more friendly on this version. First off, we've logically grouped all of these parameters into their components so that you can kind of understand where they're going with. For instance, we've grouped all of the token information under a token section. Same for proposals, neurons, and voting. We've also added quite a few quality of life updates. One of my personal favorites that I'm going to brag about, shout out to Daniel Wong for coming up with this idea, is adding a checksum at the end of the distributions. A lot of people were having a hard time doing millions of SNS token distributions and making sure the math added up. So we've got this little checksum at the end to verify. We've also added a humanized library that makes specifying all the different units a lot easier. So no more specifying E8s in the trillions, you could just do tokens now. We also have lots of different durations that you can specify in years, weeks, days, seconds, whatever you want. So enough of that. I want to show like how easy it is for a dev. So as I said, I'm using SNS testing, and we've done quite a bit of scripts here. But for the new one proposal method, they're very simple, okay? They're really just executing that underlying SNS CLI binary. So what I did here was that first step I outlined in the developer experience, right? You just add a co-controller of the NNS to your root, to your DAP canister. So I just use SNS prepare canisters, add NNS root, and that's my canister ID, and bam, it's ready. So I've already shown you the config file. Let's actually use it to submit an NNS proposal and see it. So I'm using propose SNS.sh, and this will read in, interpret the file, and then actually submit the proposal to the NNS on your behalf. Again, this is different from the previous methodology where you deploy the SNS. Now it just submits it to the NNS. So this will just take a quick second to run. Seems like we're seeing some action, and loaded configuration, sending the proposal. SNS OGs will remember the smiley dap DAO from many of my previous presentations, but it looks like the proposal has actually been submitted. So now, as an NNS voter, let me go see what it's like to see one of these proposals. You can see it's already submitted here, and it's under the SNS Neurons Fund topic. And I'm testing locally, so I've already had this adopted because I just wanted this to pass. But you can see here that all of the information that was outlined in the config file is now available for you to be able to review and exactly understand what this SNS is going to be created with and be doing in the decentralization swap. So for instance, you can see that the DAP canisters is specified here, and you can actually see it down here in the config. Now, once this is adopted, the autonomous execution of that proposal and creation of the SNS is going to go underway. I'm going to not show this today because I know I'm coming up to the end of my demo time, and I want to do one last slide. So yes, at this QR code, we've posted today an update on the release and all of the changes to the process in a forum post. If you follow this QR code, we have the forum post here. Feel free to ask questions there. I'll be monitoring it for the next couple of weeks, but it also outlines when the release is going to be in early August. Finally, I want to do a plug for the NNS team. We've been religiously posting to the forum all of the change logs that are going out for the various NNS canisters. If you want to follow along and see when this feature is going to get enabled via an NNS proposal you can vote on, be sure to check out the developers and NNS tag. That's it from me. Thanks, everybody, and feel free to ask any questions in the chat.
Hey, Daniel, thanks so much. I guess it's incredible how quickly time flies when you see all this great work presented externally, internally, and we're not even done with it. So the next one is about DFX deploying to a playground. So Jason, yeah, how can I get some canisters up and running quickly?
Thanks, Jan. Hi, everybody. Jason here from the SDK team. So I want to talk to you about playground deployments. What is it? It's a simple, cost-free approach to deploying canister to the IC mainnet. And why do this? Well, developers ought to be given a chance to kick the tires and satiate their curiosity without investing heaps of time, effort, and energy up front. And what have we done? How do we accomplish this? Well, we thought we could augment the DFX deploy command and leverage the power of the Motoko playground to make this possible. So let me build up the motivation here. The current path to deploying to the IC, at least on mainnet, is involved. Our documentation alone contains over 15 steps. And that's not even counting the steps involved in acquiring ICP, converting to cycles, and transferring that to a wallet canister. For a developer that's new to the platform, that can be overwhelming enough to walk away. And just as a quick comparison, virtually every cloud provider out there provides a low-cost path for developers to get started on their platform. They realize that developers will naturally gravitate towards the path of least resistance. And it's not just the crusty Web 2 platforms either. Many blockchains offer similar paths to onboarding developers and bringing them into their ecosystems. Here we have testnets and faucets galore. ICP, we have a cycles faucet, sure, but I think we can do even better, and we can improve the developer experience for new developers even more. I'm happy to announce a new feature that we're launching, and it's a brand new way for developers to get started with building dApps on the IC that requires virtually no knowledge of ICP, cycles, wallets, or any other potentially complex topic. All you have to do is run dfx deploy -- playground, and your canister will be live on the IC mainnet. And I'm going to show you just how easy that is. So here I have a project. It's a simple Hello World project. This is the project that would get created if you just ran dfx new. And I can show this here for us. That's the project. And at this point, let's say I'm ready to just deploy it to mainnet. I kind of want to test this out, kick the tires, just run it. So previously I'd have to run through a bunch of steps and go through a lot and understand cycles. Now all I have to do is run dfx deploy -- playground. Oops, sorry, let me run it in this window here. And what this will do is it'll build my canister, it will reserve canisters in the Motoko playground, and then it will deploy those, deploy my code into those canisters. And this will take, roughly 30 seconds to a minute. And by the end of this, I'll have a canister URL, and I can use that then to see my app. I think I may have stopped sharing, so let me share that one more time. Okay, you can see this. I ran dfx deploy -- playground. I got all of this output, and then at the end of it, I got this URL. So I'm gonna show you that. I'm gonna visit that URL and show you. There's the Hello World app live on the IC. And there it is. All right, so great. This will be available in DFX 015.1. Please head over to our GitHub to take a look. And as always, please provide your feedback by visiting dx.internetcomputer.org. And I'd just like to thank Severin for being the brain and the brawn behind this, and Yan Chen for the Motoko playground and giving us the ability to unlock this. So yes, thank you very much, and back over to you, Jan.
Thanks, Jason. Really great as well. Can't wait to test it myself. So the last one is another pain point that developers have all the time. So Lin Wei, how can we help?
Yeah, sure. Hello, everyone. This is Lin Wei, also from SDK team. I know we are a little bit over time, but I will do it quickly. I believe it worth your time. So what is putting canister dependencies? DFX supports putting canister dependencies directly from the IC mainnet now. And the pool canister can be deployed locally and has integration with it. Why do we want to do it? We believe the interoperability of canisters on the IC is a vital feature. but currently it required a lot of manual work to set up canister dependencies. So how can I do it better? There always involve two parties, providers and consumers. So providers will need to attach some required metadata, and consumers can fetch the metadata to know where to download the WebAssembly and how to initialize the canister. But all these things are handled automatically by DFX. Let me reiterate a little bit of our motivation. So currently, a typical workflow that when people want to integrate with a third-party canister, we always need to first find the source code repository, and we often need to set up build system if there is no pre-built WebAssembly module provided. And it often takes time to figure out the init argument types, because init arguments are required to install the canister. And we also need to deal with different canister ID on local replica versus on the mainnet. So we definitely need to have some better developer experience here. So today's demo, say we already have a service canister. As you can see on the top right, it have a canister ID there. And if I have some my own app canister that I'm developing and want to make inter canister call to the service canister, how can I get that on-chain canister to my local replica and test all the integration? So here is a very simple project I have locally. Basically, there are only two files, one DFS.json and one source code of my app application. By looking at the DFS.json file, you will see some interesting part. Beyond the app canister, there's a service canister defined below, and it have a type pool. And I just entered the canister ID of it on the mainnet. Then I can directly run DFX depth pool. It's quick. What happened? I will show you. There is a new depth folder in my project, and let me show the contents of the files. Yeah, so it kind of records some metadata of the pooled canister. And also we can see the candidate file of that canister. You can see there is a get method of this service canister, and that is the method we will call from my own app canister locally. So there's still some steps we need to take. The first one is we need to set up the init arguments. Okay, it informed you that I definitely need to set init argument for this canister, and it also tell me what the required type it is. So now I can do it. I set one as init arguments to this service canister. We can see there's a new file showed up here, which is the init.json, and also under depth folder. It recorded the init arguments I just set in this file. And now I can deploy the pool dependency locally. First, I start a local replica as usual. Then I run dfx steps deploy, which creates a canister and install canister to the same canister ID as on the mainnet. This is happening on the local replica. And then we can get back to the source code of my own app canister. I import the service canister, and I create a double service method. When you look at the function body, you'll see I make a service.get inter-canister call, get the result from it, double it, and return it. So if the service get returns something like 1, this double service should return 2. Let's verify it. So first, we deploy this app canister locally first. You may be very familiar with this procedure, some wallet canister creation, deploy, And now the app canister is also deployed on the local replica. So we can make some function call. First, we directly call the service get method. It should return 1. Yeah, it is. And then we can also call the double service method of app canister. It returns 2. So definitely we are verified that the integration is working. The app canister can make intercanister call to the service canister locally. So basically this is a demo, and let me get back to the slides. So let me recap the consumer workflow a little bit. As a consumer, we only need to get the canister ID of the dependency and declare it in dfx.json. And then we just run dfx deps pool, dfx deps init, then dfx deps deploy. The dependency canister will be running on the local replica. So behind this magic, what happened before? So it's a cooperation between provider and consumer. A provider, they need to configure their canister to be poolable and build it. Then this canister will have a metadata which contains some very important information. The most important one is WASM URL. And then the provider will deploy it to the IC mainnet and also publish it to the web service. So the web service can host a WebAssembly file via the WASM URL. And one example could be github.com release artifacts. And as a consumer, it will first fetch the metadata from IC mainnet and know the WASM URL which contains in the metadata and points to the web service, and then download the WebAssembly module file from that web service. All these are handled by DFX automatically. So what's next? We want to make DFINITY canisters poolable, and the exchange grid canister is already poolable. It is the first one. And another thing we want to do is we want to make it possible to download WASM module directly from the IC. Then it will be a 100% on-chain solution, and it will be less work for service providers. As you can see, there will be no other web service involved in this workflow. The provider can build and deploy to IC directly, and consumer can fetch and download from IC also. So if you want to know more in detail about this nice new feature, you can check the following links. It like the pool dependencies overview and a CLI document of DFX steps, subcommands. And there is also a guide for those service providers who want to make their canister poolable. Thank you. This is my demo.
Thanks everybody for attending. Thanks everybody for presenting. And as we're over time, goodbye. See you next time. Bye-bye.